Stay classy, Golden Eagles. So this is going to be the third lesson, or sorry, the third video for the fourth lesson of the week. The lesson that you guys did for Tuesday and Wednesday was all about classifying triangles. And that is either just figuring out whether an angle is acute or triangle is acute, a right triangle or an obtuse triangle. And so you did pages 2 and 3 on that, and it was about 14 problems for those 2 pages total. Today, it's going to change up just a little bit. And today, you guys are going to go ahead and continue to classify triangles as classify triangles as acute, right, or obtuse. But this time, you're going to do one little extra bit, and that is going to be figure out the number of acute angles, the number of right angles, and the number of obtuse angles in a particular triangle. And I'll go ahead and walk you through one particular example, and it should make a little bit more sense. And there's a few key tricks that can help you out every single time to make it kind of easy. So first off, the learning target is I will be able to tell the number of acute, obtuse, and right angles, and then classify a triangle as either acute, obtuse, or right. So you'll be able to tell the number of acute angles, obtuse angles, and right angles, and then determine whether a triangle is right, obtuse, or acute. So that last one right here is one you've been practicing for 2 days. The one up here up top is what we're going to focus on today. So just for a quick reminder, I wanted to go ahead really quickly and go over what an acute, a right, and an obtuse angle are. Remember, angle is a vertice where 2 lines or 2 sides meet. So it's either a vertex or a vertice, and that creates an angle on the inside part there, all right? So acute angle is less than 90 degrees. Remember, 90 degrees is right here. Acute would be less than 90 degrees, whether it be just slightly in or almost all the way down. That's an acute angle. The second one is a right angle, and that is exactly when it's 90 degrees, straight up and down. When a vertice or 2 sides meet perfectly straight, and it goes up like that. And last but not least is the obtuse angle. Obtuse is anything greater than 90. So if this is 90, that's an obtuse angle, even though I just moved it slightly. Remember, right angle equals exactly 90. So this could be an obtuse angle, or all the way down to the ground could be an obtuse angle, okay? So, again, acute is anything less than 90, a right is exactly 90, and obtuse is greater than 90, okay? So the activity that you guys will be working on today is going to look very similar to this, okay? And it's going to have kind of a graph set up, and here is your example. So it's going to give you an example triangle, and then it wants you to turn the number of acute angles, the number of obtuse angles, and the number of right angles, and then finally classify it. Is it a right triangle, is it an obtuse, or is it an acute? Okay, so let's go ahead and take a look at this particular triangle that we have right here. Let's go ahead and start at the top with this particular angle. Now, if we just look at that one, is it perfectly straight up and down? No, it's not. Okay, if it's not perfectly straight up and down like you see where my pen is now, is it bigger, bigger than that? No, it's not. It goes in, so it's less than 90. So that is one acute angle. So I'm going to go ahead and put a little dash in my box so I can keep track of my number of acutes. But that's not my total number. I've only looked at one vertex. I still have 2 more to look at. Let's look at this one down here. Okay, where the 2 sides meet at this particular vertex, is it greater than 90? Remember, is it exactly 90? I always like to judge it as 90. So if my pen were to be the other side, it would meet perfectly here and create a 90-degree angle. But it's smaller than that, right? It's not bigger. Bigger would go this way. Smaller would bring it in. So that's another acute angle. Okay, we still have one more to look at, so I'm not going to go ahead and decide quite yet. Okay, the last one is here. All right. Now, I did my best. I'll give you the point here. I did my best to make this a perfectly straight, 2 perfectly straight sides that meet up. And I can look and see, be like, yeah, they are. It's not bigger. It's not obtuse, so it's not bigger than 90. And we have 2 others that are acute, so that has to be a right triangle. A right angle. So I put a tally mark over there. Now, I can go ahead and figure this out. So I had 1, 2 acute angles. I had no obtuse angle, so I put a 0. And I had 1 right angle. So I can put a 1 there. So now I can classify this triangle. Now, if you remember to the previous day's lessons, an acute triangle has all sides that have less than 90-degree angles. So if the number is ever 3 here, it's an automatic acute triangle. If it's less than 3, it cannot be an acute triangle. So we can go ahead and forget about that acute. Now there are 0 obtuse angles, so this cannot be an obtuse triangle, right? If there is ever any 1 in the obtuse, then it's an obtuse triangle. If there is ever a 1 in the one of the angles that is a right, it's always going to be a right triangle. And that's the quick trick on this, guys, okay? If a given triangle ever has 3 acute angles, it's an acute triangle. If a given triangle ever has 1 obtuse angle, it's an obtuse. You'll never have a triangle that has more than 1 obtuse, but if it has 1 obtuse, it's instantly an obtuse angle. Same thing goes with a right triangle. You can never have more than 1 vertex or 1 meetup of sides. You can never have more than 1. There can never be a triangle that has 2 right angles. It's impossible. Okay, so if you ever have just the 1 in there, it'll only ever be 1, it's an instant right triangle. Same thing with obtuse. If there's 1, it's an instant obtuse. Acute is only when all 3. So if you ever have a 3 in here, it's going to be an acute. If you ever have a 1 in here, it's going to be obtuse. If you ever have a 1 in the right, it's going to be a right. Okay, so that is the quick and easy way that you guys can go ahead and do that. So before I end the video, I want to go back to the learning target. The first part of it was I will be able to tell the number of acute, obtuse, and right angles within a triangle. So angles are where where a vertex is, where 2 sides meet. The inside measurement, which we will get to eventually, is how we determine whether it's acute, obtuse, or right. And finally, then after that information, you'll be able to decide if it's a right triangle, an acute triangle, or an obtuse. If you have any questions, as always, comment in below this video, email Mr. Holt or email myself. As always, stay classy, Golden Eagles. Don't forget to do page 4. If you're doing the whole list where you have pages 1, 2, 3, and 4, and then page 6 will be the last one that we do this week. Use that one doc, or if you're doing it day by day, go ahead and do that. Make sure you turn in everything when you're done. As always, stay classy, Golden Eagles.